Let's get this started. I hope you see my screen. I'm going to be talking about the automated security and compliance to you today. And as Harshil mentioned, he's been with me on the same project. And this is what I looked like back then, going through endless Excel sheets, endless pieces of documentation, taking screenshots, writing down checklists, going into meetings with security people, going into meetings with compliance people, trying to get this message across that, well, we as developers did the things we needed to do to keep the product secure and keep the product compliant we're building for our client, right? So this was a couple of weeks before we were ready to launch a brand new product for one of our banking clients that was supposed to transform how they do lending to their customers, right? So everyone was super excited. Everyone wanted to get this thing out into production and get it in front of customers. Yet here I'm sitting with this slightly unhappy face, trying to get through this compliance documentation and trying to get all the things right and get everyone convinced and everyone on the same page that we were doing the right thing. And I'm guessing I'm not the only one who's experienced that in the past, right? So as developers, we often look at security and compliance from this perspective of this is a blocker to us, right? A security team comes to us and says, like, here's the list of requirements that we need you to fulfill. This is the process that you need to go through before you can release something into production, before you can make a change, before you can actually start building a new product. So from our perspective, right, we want to get stuff out into the market, right? So this slows us down. It can even make our releases more risky in the long term, right? Because, big process upfront makes releases more expensive. You do them more often. What happens if you do a release less often, right? Then there's more stuff in a release, right? There's more stuff to go wrong. And on top of that, right, often we see this kind of process as very boring, repetitive. It's something we need to go through over and over again. It takes a lot of our time. It's simply just a hassle for everyone involved, right? And I know this feeling because, as Harshil mentioned, I've had this feeling myself. But I'm not just a developer. I'm also someone who works with security and compliance folks from every now and then, and can also see this from their perspective. And they're telling me a very different story from what a developer might tell me, right? When they're looking at someone releasing a product into production or simply deploying a change, right? What they're seeing isn't so much all the fancy things that developers are excited about, right? What they are seeing is risk and danger, right? Every time you make a change, this is something that can go wrong. This is something that can open up a big hole in their compliance posture. It can open the door to bad actors, to cyber criminals. It can damage a company's reputation. It can make them go out of business. It can hurt the customers the organization has. And it can be really expensive too, right? When you're seeing some of the things that happened in the past few years, right? GDPR has become a thing in Europe. $1 million fines for security incidents have become something that is actually happening, right? So when you're talking to security and audit and compliance professionals, right, this is all the stuff that is in their head, and they don't want any of this to happen, right? It's their job to make sure this stuff doesn't happen, right? So they see things that developers see as exciting, as dangerous and risky. So what do we do then, right? Are the developers right in saying, like, no, we need to release faster and faster? Or are the security people right that tell us, no, slow down, let's take this the old-fashioned way, let's look at it one more time? And from my perspective, the answer is both, right? Yes, as developers and as product people, getting something out of the market is how we provide value, right? Software is only valuable to us if we can release it into production. It's no use in a dev environment. On the other hand, we're not providing any value if that piece of software is broken, if that piece of software doesn't comply with the regulation we're under, if that piece of software isn't secure enough to keep our customers safe, right? So where do we go here from this perspective, where we need to where we have a set of tasks that we really need to get right? Right? We have these security tasks that we can't really afford to do wrong very often, but it's also very repetitive and very boring and very exhausting for us to do. Well, we're doing the things that we always do as developers in these circumstances, right? We let a computer do these kind of things, right? Because computers are great at repeating the same task over and over again without making many mistakes, or without making any mistakes. So this is what I want to talk to you about today, right? How can we automate some of the things in the security and compliance space that we used to do manually, and therefore go out into production faster without compromising our security and our compliance? And the way I'm going to do this is I'm going to show you a couple of things that often happen, that we often find in requirements documents. I'm trying to translate those into, let's say, more human readable words, and see if we can find an angle that way of how we can automate some of this. So let's get started. First, the one you will almost certainly find in a bigger organization is the OWASP top 10, right? Organizations must ensure that all applications are protected against the OWASP top 10 vulnerabilities. You'll find that in pretty much any security requirement document. For those of you who haven't heard of the OWASP top 10 before, it's a list of frequently made mistakes in the security space. As simple as that. So one way of translating this into more digestible words is, we don't want you to make any mistakes that everyone else is making, right? We don't want you to make any commonly made mistakes. And so if we can find out what a commonly made mistake is and what that looks like in an application, then maybe we can find a way to automate some of this. Let's start with our code, right? If we can find out what a security vulnerability looks like in our code, we can use static analysis tools to find these kinds of patterns, these kinds of dodgy cases of code that might indicate a vulnerability. And there are tools out there that do that, right? They're typically coming out of the space of static analysis, and they allow you to search your code base for commonly made mistakes and commonly made patterns in code that indicate vulnerabilities. So what you're seeing there in the screenshot on the right is one of those tools. It's called Find Sec Bugs. It's one of the tools out of the JVM ecosystem. And what it found here was that we've used some user input, and we concatenated it into a string and used it as a SQL query. Right? This is the classic SQL injection that most of you have probably heard about before, right? And we now have automation in place, can find these kinds of things in our code base and warn us, right? The tool you want to look for is static application security testing, or SAST. I've put a couple of frequently used open source tools there. They're down there, but you will probably find them for any language just by Googling for SAST and the name of your favorite programming language. So they will find weird looking pieces of code in your code base, and they will warn you if they indicate something security relevant. So you can go in and you can find that. And I've used those in projects as well, and they have actually found really interesting things. So have a look at these tools if you want to know, like, are there weird things in my code? Moving on, right? So now we know things that look weird in our code, but we can also look at this from the perspective of like how a QA would look at our system, or how a pen tester might look at our system, right? What they're doing isn't so much looking at our code. They also do that. But more importantly, they take our system as a black box and try to treat it in a way as an attacker would do, right? So they look at the system, they try to find out how it works, and they try to misuse it. They try to put weird input into your system to see if they can exploit anything. And some of these things require a lot of creativity, a deep understanding of the code, and a deep understanding of the technology. And pen testers and QAs are really good at doing that. But there's also a large number of things they do that is more repetitive, right? That is, I have an API here. I'm just going to throw as many different weird inputs as I can at the system and see if anything sticks. And this is something we can automate. OWASP there on the slide is the open source tool, but there are also commercial alternatives as well, right? And that is exactly what these tools are doing. In the screenshot that you see here, what I found is that there is an API in our system that's called /session, and it takes a vendor parameter and a post method. And what it did is it took a normal parameter, right? So the vendor HVAC company in this case, and modified it a little bit, right? It added this weird quote and 1 = 1 thingy to the input. And I found out that it can actually log in and actually do valid things with that API by putting in this kind of input, therefore indicating that maybe this is a SQL injection vulnerability, right? So again, very important tool for you to try out. Look for dynamic application security testing, look for OWASP ZAP, look for burp suit if you want something more commercial. And then you got two different very good perspectives of finding security problems in your code. But there isn't just your own code that you deploy, right? You're also deploying alongside your code, the code of all the libraries and frameworks that you're using. You're deploying the operating system packages and the tools that you installed in your Docker container or on your server. All of this kind of stuff obviously can also have vulnerabilities, right? Because their developers are also just human. They also make mistakes. Thankfully, for most of the commonly known libraries and tools and frameworks that you will know, there are databases out there that can tell you for every version of that software, are there any known vulnerabilities? Which versions are they in? Which versions are they fixed in? So what we can do is we can take these databases and we compare them to our dependency tree and see if anything matches. And what you see then there on the right is exactly the output of one of those tools. This one is Trivy, that works on Docker containers, but also on individual applications. And it just compares the libraries that you're using, the tools that you're using, against commonly known vulnerability databases and see if there's any match. And then it can alert you. It can also sometimes tell you which version you need to upgrade to not be in danger of such vulnerabilities. And then there are other tools out there for particular package managers that you can also use. Just search for dependency checkers and you will find a lot. One that is worth calling out is the tools that are now built into GitHub and GitLab, right? So things like Dependabot, because they can not only analyze your source code and find vulnerable dependencies, and they can also create pull requests for you, which means that tedious task of patching your vulnerabilities and patching the libraries you're using becomes much more easy, right? Because the pull request is automated. You just need to have a look at it. You just need to run your tests against it, and then you can just merge it. So you have a semi-automated vulnerability fixes in your system that way. So if you're using some of these tools, what does that look like? Well, I really want to encourage you to build these tools into your CI/CD pipeline, right? So that you not just get feedback on the functional side of your application, right? Does it build? Does it test? Can we deploy it somewhere? But also on the security and the compliance side of things, right? Add some of these tools to your pipeline, and you will get feedback on your security posture, not in a matter of months, right? Whenever the next pen test is due, or whenever the security team has time to look at your code. You're now getting feedback pretty much in real time. Whenever you make a change, your pipeline runs, it can tell you whether there's anything wrong with it. You can fix it immediately, right? So you make your applications more secure and you get faster feedback. It's way less tedious this way. So that's the application side of things. But if we're looking at cloud native applications, they don't live in isolation, right? There is infrastructure around those applications. There is databases and storage and network and load balancers and all this other kind of stuff that obviously also needs to be secured. So what about those things? What you often also find in hardening and security guidelines, right, is this thing about like your infrastructure must be hardened against a particular standard, right? Something we very frequently find. One way to translate this is in more human readable words. From experience, we found a couple of rules that indicate that you're building good infrastructure, right? So please prove to us that the tools that you follow these rules. So how can we automate that? Well, if you ask me, a set of rules that I need to validate sounds a lot like testing. And thankfully, the open source world has become a lot better in building testing tools for infrastructure these days. So tools like GOS, ServerSpec, InSpec are really robust and really flexible right now. And you can use these tools to create rule sets, for example, against your servers, right? So you can automate all these rule sets that your security folks came up with, just like you would write any other test. And what you see on the right is one example of such a rule that would validate. In this case, did we set up the right ownership and the right permissions on our SSH server configuration? Right, and these lists go on and on and on and on. So it can be a bit tedious writing these things ourselves. Thankfully, most big organizations don't come up with these rule sets from scratch, right? They use one of the commonly known sets of rules that are out there that the community has come up with. I think one of the famous ones is CIS. So thankfully, the community has also done the work of automating these rule sets. So DevSec.io is there on the slides. It's exactly that. It's an automated way of checking for, in this case, the CIS benchmark for server hardening, right? So if you're following one of those well-known standards, you can just download this rule set, run it against your server, and it will give you a report that says, like, you're following all of these rules. You can give that to your auditors, your compliance, or your security people and say, like, hey, you wanted CIS? Here's the list of things we have done. I think we are good there. So that covers your server. But there's a lot more than just servers in our infrastructure, right? And there's a lot of other cloud infrastructure that we want to look at. Thankfully, there's also great tools in the infrastructure space now to look at those, right? So you talk about AWS spec, Terraform compliance. These tools allow you to write tests against the infrastructure that either that you've already deployed and just scans your AWS account, or it actually looks at your Terraform code and your Terraform plans to have a look, what are you going to deploy? And does that comply with the security rules we have, right? So you can write rules like this one that I highlighted, where I'm saying, I'm not building a publicly accessible app right now. So please check that I don't have any open ports, any open security or firewall rules that open something to the internet, because that's not something I need, right? So let's close that. Other point, the open policy agent is something that I want to call out as a really interesting tool because it is a bit newer. It has a bigger learning curve. I must warn you of that, but it's more powerful as well. For once, it supports multiple different cloud services and supports multiple different infrastructure tools. So your Kubernetes or your most favorite service mesh, I think Terraform as well, right? All of these are supported by Open Policy Agent plugins, and you can write really powerful rule sets with that. So the one you see there on the right, for example, is a rule set that essentially says, I only want to deploy images that come from my own hardened image repository. I don't want to deploy random stuff from Docker Hub because I don't know what that really is, right? I just want to deploy things from my own repository where I have more control over it, right? You can build these kinds of policies into Kubernetes and into many of the other tools you're using the Open Policy Agent, and it automatically enforces these rules for you. It prevents you from doing some of the things that you might be doing wrong otherwise. All right, so this is very good for organizations that have a large number, a big number of people that have good rules already in place. What if you're a smaller organization or you're just getting started with the cloud? Then most likely you will not have the security team or these experts in place that will tell you exactly which rules you need to follow for infrastructure. But you probably still want to make sure that you didn't make any too bad mistakes with the infrastructure. And again, there are tools that can help you do that. So what you're seeing there on a screenshot is a tool called Scout Suite, mainly in the AWS space, that can check an AWS account for many odd misconfigurations that people often do wrong, right? So think publicly accessible S3 buckets. Think missing a second factor on your IAM users. Think many other things that are commonly made mistakes across a wide variety of AWS services. You run it against your AWS account. It needs read-only permissions only, and will come up with a report for you that you can then validate and see, like, are there any things I should be worried about? A similar tool in the space is Prowler. It does very similar thing. It can make sense to run both tools just to see if one tool finds more than the other. Also worth pointing out, our cloud providers these days are really good at building these kinds of tools into their clouds in the first place. So have a look at AWS Security Hub and have a look at the Azure Security Center as some of the provider supported tools for infrastructure security. They can do some audit log scanning, they can do some infrastructure security scanning, and many other things as well. So yeah, have a look at those tools as well. And obviously there's also third-party commercial tooling that you can also have a look at. One last tool I want to call out is TFSec, because it's basically the static analysis equivalent to the SaaS tools we talked about before, for infrastructure code, or more specifically for Terraform code. So this can be a great tool because it runs before you actually deploy something, right? This happens early on in your pipeline. It's fast, and it can give you fast feedback where in the infrastructure code is actually a problem, right? So this can be a lot easier feedback than having to scan a whole AWS account. Most likely, you will want a combination of multiple of those tools. A few other things that are probably a talk in its own right, so I don't want to talk too much about them, but just for you to call out some other things that you might be worried about. Once you deploy to production, right, how do you monitor things, right? Are there ways to find out if someone is attacking you? Do you want to repeat your dependency checks to be aware of any dependencies that you didn't know about were vulnerable before? How do you monitor that things are continuing to be okay once you've deployed? There's some stuff around audit logs. There is also some things you might want to consider around reporting. What we've often seen is, right, we've introduced all of these interesting tools, but an auditor, right, or a compliance person typically isn't very technically sophisticated, right? This is not their job. So they aren't necessarily fans of us walking them through our CI/CD pipeline and pointing at technical reports, right? So there are tools out there that allow you to extract the information from your technical tools and reformat them into, for example, a Word document or an Excel spreadsheet of your compliance people's choosing, right? So they can take that to their auditors, print it out, show it to the auditors saying, hey, here's our report, we did everything right. So these are some lessons for the future. But in general, right, if you apply any kind of subset of the things that I was talking about today, you have pretty solid security automation. You have done a great job of giving you a faster feedback cycle when it comes to security and making your systems more secure. In fact, I would probably say you're doing better than most other people out there at the moment. But I started this talk talking about my frustrations with our clients and how I needed to go through many pages of documentation and how we got into this culture clash, right, between security, compliance, developers, product people. Are a bunch of tools going to solve that for you? Unfortunately, I need to tell you, no, they won't solve this problem for you, at least not on their own. they're a good step in the right direction, but it won't solve this problem for you. So how do we solve that problem then? Well, you need to look at one last thing, and that is the human factor. Turns out the technology we're using and the tools and frameworks that we're using can only ever be as good as the humans who work with them and their understanding of it and their acceptance of it, right? So if you really want to break this divide between security and compliance and developers, you need to start looking at the human factor. You need to start engaging with people. You need to become a change agent. And where to start is probably your own team. If you're the change agent who introduced all of these tools into your team's workflow, you might get some pushback, right? Because you introduced that tool and now that tool found something, right? It found vulnerable dependencies and now the build is red and your team doesn't know what to do with it. Or they fixed the build because of these vulnerable dependencies and 2 days later it's red again because, well, there are new vulnerabilities now. Right, so this can annoy your team if they don't understand it well enough or they don't know how to handle it well. So very early on in your journey, talk about these things, try to find solutions for the things that will come up. So things like, if this tool finds a vulnerability, how do we react to that? Do we break the build and block the pipeline, or are we maybe still okay to release? Is it a case-by-case decision? Then who will make that decision? Who will be able to fix that thing? How will they fix it? What is actually the value of doing some of these things? And do I need to do them right away? If I'm only ever going to release every 3 months, right, then maybe I don't need to fix vulnerabilities every single day. Or maybe I need to because they actually point a really bad problem in production. Right, so have these conversations with your team and with your stakeholders early. How you're going to use the tools that you've introduced into the workflow, why they're effective, and why you should continue doing and investing in them. So that's for inside your team. The second part is all the people outside of your team, right? Developers and infrastructure people and security people and compliance people come from different worlds. They come from different skill sets. They have different incentives. They have different things they're worried about or they're excited about, right? And you only get that understanding for each other if you start to get to know each other. So empathy is the key to get to collaboration with them, right? Take your counterparts out for coffee, take them out for drinks or for a good lunch. Try to understand each other's worlds. Try to understand what their worries are. Try to understand what the problems are that they're facing. See if you can do your counterpart a favor instead of just asking for things from them, right? See if you can solve a problem for them or if they can help you with something. Because more often than not, right, the other side doesn't want to be a blocker, right? They want the business to succeed, but they need help from you and you will need their help to really get good at this. So what does good look like then if you're doing all these different things that I talked about today? Well, what you're doing is you're shifting your manual work left, right? Your automated tooling, once you've checked in code, will take care of your day-to-day security, It will figure out for you, right, if you did any bad mistakes. At the end of your continuous delivery pipeline, after having run through all this code, you can probably be quite confident that you didn't do anything too wrong and that you're ready for production. Which means that now, as developers, as security people, as compliance people, we don't need to worry too much about these things anymore. And we can spend more time early in the delivery cycle, right? We can now spend time doing more exploratory testing. We can now spend more time going into analysis and add maybe threat modeling to the way we design our software and the way we analyze the work we want to do. We can spend more time learning about security and how to build more security into the process in the first place, right? Because the automation took care of the boring and repetitive parts for us. As developers and as infrastructure people, as security people, as compliance people, we can now take care of the interesting things and we have much more time to do that. So as you're going to that, you're now building an environment where all these different people come together and collaborate into a design where you can deploy to production much more often than you did before in a much safer way. You're getting faster time to market for a more secure product. And what's not to love about that? Thanks everyone for listening to that. I will be on Slack for a while, so hit me if you have any more questions, and I'll throw it back to Harshil.
Thank you, Florian. Thank you very much for the brilliant talk. Definitely it brings back a lot of memories for me working on a project with you, and definitely a proud moment, even though, as I said, excruciatingly painful to see you and the team go through all those things. But just to see that we did everything that you mentioned on this project is really inspiring. Thank you for that, Florian.